All right, let's dive in. We all hear it constantly, right? AI is changing everything. But what's actually going on under the hood? Forget the buzzwords for a minute. Today, we're going to break down the 7 key ideas, the real building blocks that are powering this whole revolution. Stick with me, and by the end, you'll have a crystal clear picture of where this is all going. Let's do it.
And I mean, AI is heading everywhere, isn't it? This quote is pretty funny, but it's also a perfect sign of this massive shift. You know, the same basic ideas that let a toothbrush get an AI update are the very same ones at the heart of the most powerful systems we're about to talk about, just, scaled up in a huge way.
So yeah, that brings us to the big question. We get it. AI is here, but what's really happening? And more importantly, how does an AI go from just finding information, kind of like a fancy search engine, to actually doing stuff in the world? That's what we're here to unpack.
And the answer starts with our very first big concept, this major shift from a passive AI to an active one. We are officially in the era of AI agents, systems that aren't just designed to talk, but to think and, crucially, to act.
So what exactly is an agentic AI? Well, here's a great way to think about it. Imagine you're building a house. A normal chatbot, that's your hammer. It's a useful tool, but it only does one thing, and only when you swing it. An AI agent, though, that's the general contractor. You just hand it the blueprints, the final goal, and it figures out everything else. It lines up the plumbers, the electricians, and manages the whole project from start to finish. And this is basically the engine that makes them go. They run on this continuous loop. First, they look around and perceive the world. Then they think and plan what to do next. Then they do it, they act. And finally, they look at what happened, they observe the results, and that feeds right back into the top of the loop. Each time around, they get a little bit smarter, learning and adapting as they go.
So, what could these agents actually do for us? Oh man, the possibilities are pretty much endless. Think about an agent as your own personal travel agent. And I don't mean just finding flights. I mean booking the whole trip. Flights, hotels, cars, even restaurant reservations, all based on what it knows you like. Or what about an AI data analyst that's constantly watching for weird trends in a report and then flags them for you with an explanation? Or even a DevOps engineer that finds a system crash, figures out why, and fixes it all on its own.
Okay, but for an agent to pull off these complex multi-step plans, it needs a pretty special kind of brain. And that's where large reasoning models, or LRMs, come into play. A standard LLM is kind of like a brilliant student who's amazing at multiple choice tests, just incredible at pattern matching. An LRM, on the other hand, is more like a seasoned detective. It can take a really complex case, look at all the evidence, and piece together the solution, one step at a time.
And you've probably seen this happening already. You ever ask a chatbot a tough question and it pauses with a little message like, thinking or working on it? Well, that's it. That's the LLM doing its thing, running through an internal monologue, a whole chain of thought, before it gives you a carefully considered answer or decides on its next move. So, we've got an AI that can think and act. That's awesome, but there's a problem. Its knowledge is stuck in the past, limited to whatever it was trained on, which could be months or even years old. To be really useful, it needs a live connection to the outside world. It needs a library card to the world's information. And that library is our next big term, the vector database. Now, this is not your average spreadsheet with rows and columns. No. Instead of storing words or pixels, it turns everything, text, pictures, sounds, into these really complex strings of numbers called vectors. And the magic is, these numbers capture the meaning, the context, the whole vibe of the original data. And that right there is the game changer. Because all the data is stored as meaning, the AI can search for concepts, not just specific words. You could literally ask it to find documents about that time we had a frustrating customer support call, and it would find them, even if the words frustrating or customer support aren't in there at all. It just gets the relationships between ideas. Which, of course, brings up the next logical question, right? It's one thing to have this amazing, super smart library, but how does the AI actually go in, check out a book, and use that fresh info to give you a better answer?
The answer is this really clever process called Retrieval Augmented Generation. Just remember the acronym RAG. This is the bridge that connects the AI to its external library. It goes out, finds the most relevant, up-to-the-minute info, and then staples it to your question before the AI even sees it.
So let's just walk through it real quick. You ask something like, hey, what were our company's sales numbers last quarter? The RAG system instantly dives into that vector database where all your internal sales reports live and pulls out the exact data. Then, behind the scenes, it adds that data to your original question. Only then does the LLM get the prompt, but now it's armed with all this fresh, factually accurate context to give you the perfect answer. Okay, so we've got agents that can think, and a way for them to access fresh knowledge. Now, let's pop the hood and look at the brilliant engineering that makes these incredibly complex systems practical and efficient enough to actually run. First up is this idea called mixture of experts, or MOE. So instead of trying to build one single gigantic AI model that knows everything, MOE is all about divide and conquer. It breaks the big model into a bunch of smaller, specialized experts. You might have one that's a genius at creative writing, another that's an expert in biology, and another that only writes Python code.
And here's the really brilliant part. It's incredibly efficient. So when a request comes in, say, to write some code, a little router inside the model says, okay, I need the coding expert and maybe the logic expert, and it wakes only them up. So as you can see here, even though the whole model might have billions and billions of parameters, you can think of those as little knowledge dials. It's only using a small slice of them for any one task, and that makes these things so much faster and way, way cheaper to operate.
All right, next up, connectivity. How do we let our smart AI agent actually, talk to all the other tools we use every day and do it safely? That's the problem a new proposed standard called the Model Context Protocol, or MCP, is trying to fix. The simplest way to think about it is like a universal power adapter, but for AI.
The magic word here is standardization. Right now, if you want an AI to connect to your email, then your calendar, then your company's database, your poor engineers have to build 3 totally different custom connections. It's a mess. MCP wants to create one single standard language for all these conversations, which would make plugging an AI into, well, everything else a whole lot easier and more secure.
So we've covered how AI thinks, how it learns new things, and how it connects to the world. For our last section, let's zoom out and look at where this is all pointing. We're talking about the quest for an intelligence that could one day match and then very quickly leave our own in the dust.
So first, let's just get the definitions straight, because they're important. AGI, or Artificial General Intelligence, that's an AI that's as smart as a human genius. It could do any mental task a person can. But ASI, Artificial Superintelligence, that is a whole different ballgame. An ASI would be to us what we are to, say, a frog. It's an intelligence so far beyond our own that we can't even really comprehend it.
And what could possibly create that huge gap in intelligence? It's this wild, mind-bending idea. Recursive self-improvement. An AI would be smart enough to look at its own code and make itself smarter. And then that new, even smarter version would be even better at making itself smarter, creating this explosive runaway feedback loop of intelligence that just goes vertical.
And the consequences of creating something like that are, well, they're monumental. As the source material says, this kind of intelligence would either solve humanity's biggest problems or create entirely new ones that we can't even imagine yet. I mean, the stakes just don't get any higher than that.
So let's wrap this all up. We've seen how AI is shifting from just being a passive tool to an active agent. We've seen how things like vector databases and RAG give these agents a giant library of up-to-date knowledge. And we've looked under the hood at the clever designs like mixture of experts that make it all run. These aren't just buzzwords. They are the real, actual building blocks of the future. So I guess the question these tools leave us with is, what kind of future do we want to build with them? Thanks so much for joining me.